Okay, so I want to pick up with section 2.1 and continue with the problems that we just left off with, just right behind that. So what I want to do now is I want to change it up just a little bit. And so let's suppose I have a problem like this. 2x minus 3 equals 7. Now, there's a couple of things here in play. First of all, I have a number in front of the x. But also notice this is a variable term. That 2 is part of that variable term. So I have a variable term, a number term, a number term. So what I want to do is I want to get the variable terms on one side, but I have to get the number terms on the other because I can't subtract these two together. But if I can get rid of this term and get it on this side, I can add them together. So here's what I want to do. I want to get rid of the subtracting 3. Well, we learned in the first few examples in the last video, to get rid of the subtracting 3, what we will do is add 3. But whatever you do to one side, you must do to the other. So to get rid of one term off of one side and get it on the other, you either add it or you subtract it from both sides. One of the two. Okay, so make sure we're still in the window here. Okay. So when I do this, the 3's adds out and leaves 2x equals 2, and then 7 plus 3 is equal to 10. Now, we're back to that 2 in front of that x, that's multiplying. So what we're going to do to get rid of that 2 in front of that x is divide, but whatever I do to one side, I have to do to the other. So I still got the variable terms on one side. I still got the number terms on the other. All right, let's do another example. So let's suppose I have this. All right, so let's suppose I have negative 5 equals negative 3 plus 2x. Number term, variable term. I want to get the variable terms on one side. I only have one variable term, so I'm going to leave that here. But I want to get the number terms on the left. So I need to get rid of the minus 3. Well, the way I do that is by plus 3 on both sides. And if you can get to where you can do this without showing that every single time, and some teachers teach it a little bit differently, I'm aware that a lot of you have been taught the words, they'll say move it across and switch the sign. So I'm not going to try to reinvent the wheel here. Whatever works for you. But the main thing is make sure that the process that you're using is getting you to the correct solution. All right, when I do that, the left side, if you lose 5 and then you win 3 back, you are down 2. On the right side, the 3's add out, and you're left with 2x. Now, is this solved yet? No. The reason is the x has to be by itself in order for it to be solved on one side. So I have to get rid of this 2. Well, this is not 2 plus x. If this were 2 plus x, I would subtract 2 from both sides. But this is 2 times x. This is that coefficient we were talking about. So what I need to do to get rid of that coefficient is by dividing. But whatever you do to one side, you have to do to the other. And when I do, the 2's over here cancel. And so I'm left with negative 1 is equal to x. And just to show you again right quick that this is the solution, watch. Let x be negative 1. What's 2 times negative 1? Negative 2. If you lose 3 and then you lose 2 more, what have you done? You've lost 5. So that is the solution. That is the only solution to the problem. All right. Now what we're fixing to do, you're fixing to see for the first time, you haven't seen a problem like this, You've seen problems where you have numbers on both sides, but what do we do when we have x's on both sides? Well, you do the same thing that you do when you have numbers on opposite sides. You have to get them on the same side by either adding them off or subtracting them off. So if you have a 5x term over here and you want to get rid of it, you have to minus 5x, the whole term. I'll show you an example. So let's suppose I have 5x minus 7 equals 3x plus 3. Okay, so let's look at this problem. Now, almost all equations from this point on will end up ultimately looking like this. I don't care if they're this long. I mean, they can be huge. And when you work them all the way down, they end up looking like this. This is what we call a two-step problem. A two-step problem is when you have a variable term on both sides and a number term on both sides. That's what a two-step problem is. Okay, so what we do is we do this in 2 steps. What I like to do is I want to get the number terms on one side, variable terms on the other. So let's identify these. Variable term, number term, or constant. Variable term, constant. So I want to get the constants on one side. Typically in any two-step problem, I generally get my x's on the left and get my numbers on the right. You can do it however you would like. It's just typically the way that I do it when there are x's on both sides. So what I'm going to do is I'm going to get my x variable terms on the left and my constant terms on the right. Let's deal with the constant terms first. Here's a constant term, here's a constant term. This one is on the right side of the equal, but this one's not. So I want to get rid of the subtracting 7. How do we get rid of the subtracting 7? By adding 7 to both sides. So I'm going to add 7 to both sides like that. When I do on the left side, the 7's add out. That leaves me with 5x. And on the right side, I'm left with 3x plus, and I can add these together because that's 2 number terms, plus 10. So I can add these together. All right. Now, the problem is you got a variable term here and a variable term here. I need to get, oops, sorry about that. I need to get this entire variable term, not the 3, I need to get this entire variable term off of this side. So what I'm going to do to get rid of it, I got to make it add out to 0. So this is a plus 3x, so I'm going to minus 3x on this right side. But if I do that on the right, I have to do it on the left. So I'd have 3x plus 10 minus 3x. Now, what happens to those 3x's? They add out to 0. But if I subtract 3x from the right side, I have to subtract 3x from the left side. Now, look at what we have left. 5x minus 3x is 2x equals, and then on the right side, the 3x's adds out and just leaves 10. Now, we're almost there. We still have a number in front of the x. So we've got the x's on one side, we've got the numbers on the other, but we still have a number in front of the x called the coefficient. The way you get rid of that is divide by it. But you don't divide by the x also, just the coefficient. And whatever you do to one side, you have to do to the other to get x equals to 5. So, let's go through now and work some 3 or 4 two-step problems. So, let's suppose I have 4x minus 3 equals to 5x minus 11. Okay. Two-step problem. Variable terms on both sides, number terms on both sides. So let's deal with the number terms first. I like to get my number terms on the right side. So this number term right here, this one right here, is not on the right side. So I want to get rid of the minus 3. To get rid of the minus 3, I'm going to plus 3 on both sides. When I do, the 3's add out, not cancel. And then on the right side, if you lose 11, but you win 3, you are still down 8. So see, that rule about adding and subtracting positive and negative numbers is very critical in this section. All right, now that got the numbers on the right side. Now, how do I get the x's back on the left? Because see this x term right here? I can't subtract it with that 8. That doesn't combine. So I have to get rid of this whole thing, not the 5, the 5x. So to get rid of this 5x, that's a plus 5x, I need to minus 5x. And if I minus 5x on the right side, which I'm going to show you, I'm going to minus 5x on the left side. Now when I do, 4x minus 5x is negative x equals 2. On the right side, the 5x's adds out and leaves negative 8. Now, sometimes students can write, when they write that, you don't have to put if you want to put a negative 1x, that's okay also. If you win 4 and then you lose 5, you are down 1. All right, that negative 1 is not negative 1 plus x, it's negative 1 times x. So to undo that multiplication, we have to divide. But whatever I do to one side, I have to do to the other. Now the negative 1's add out, or cancels and leaves 1, x equal, negative over a negative is a positive, and 8 over 1 is 8. Now this answer doesn't have to be a whole number. This could have ended up negative 8 over 13. If it is, that's your solution to the problem. All right, so let's do this. So let's look at this one. Negative 6x plus minus 13 equals to 7 minus 2x. All right, so let's suppose, or what I want to do, this is a two-step problem because I have variables on both sides, numbers on both sides. So I like to get the numbers on the right side. So this number right here, it's got to get on this side. This variable term has got to get back on this left side. All right, so what I'm going to do first is get this number term off of this side. All right, this is a minus 13. To get rid of that minus 13, I'm going to add 13 to both sides. So I'll plus 13, and then 7 minus 2x plus 13. When I do, the 13's add out. The left side then would be negative 6x. Now the right side, 7, can't add that, but you can add the 7 plus 13, which is 20, minus 2x. Or you could have written it negative 2x plus 20. Same thing. Okay, now my numbers, variable term, number term, variable term. My number terms are on the right side. Now I need to get the variable terms on the left side so I can add them together. So I need this. I don't want it on this side. I want to get rid of the whole thing, minus 2x. To get rid of the minus 2x, I'm going to plus 2x. I'm just going to put it on this same line. But whatever you do to one side, you have to do to the other. So if you lose 6 but you win 2, you are still down 4. And then the x's over here adds out, and I'm left with negative 4x equals to 20. Now, I'm almost there, but I'm not there yet. Now I need to get rid of the number in front of the x. To get rid of the number in front of the x, I have to do, this is negative 4 times x. So to get rid of that coefficient, I divide. But whatever you do to one side, you have to do to the other. And then a positive divided by a negative is a negative. And it turns out that 4 will divide into 20 evenly. Now remember, this doesn't have to divide out and be an even number. It doesn't have to be a whole number answer when it divides out. So, okay. Now, I mentioned to you earlier, I'm going to show you this with the two-step problems. I mentioned to you earlier that sometimes in mathematics, not every problem has a solution. And then there are some problems that every single number works. Let me show you an example of those two problems. Let's suppose I had this right here. 3x minus 2 equal 3x plus 8. Alright, so what I want to do is I want to get my variable terms on one side and my number terms on the other. Alright, so what I want to do is, here's my variable term, number term, variable term, number term. I want to get rid of the subtracting 2. So I'm just going to shortcut it here. Instead of writing the line back down, I'm going to plus 2 on both sides. When I do that, I get 3x equals 2, because the 2's add out, 3x plus 10. Alright, now, I want to get the variable terms on the left side, so I need to get rid of that variable term right there. The whole term, not just the 3x. So what I'm going to do, that's a plus 3x, so I'm going to minus 3x off of that side. But when I do, I got a minus 3x over on the left side. Okay, when I do this, the right side now just leaves 10. But the left side, 3x minus 3x, first let me say this, because sometimes students will do this. They'll write just x. It's not x. 3x minus 3x, if you write x, there's an understood 1 right here. So it is very important that you put the 0 in front of that x. So I've got 0x equal to 10. All right, very important what I'm about to tell you right here. Whenever your variables goes to 0, not your numbers, your variables goes to 0. This problem right here, and this is the first time this has happened, when this happens, your answer will always be either no solution, or that means nothing works, or the answer is all real numbers. That means everything works. Here's how you can tell. What do we typically do with the number in front of x? We divide by it. Well, why don't we do that right here? Because remember a while ago, one of your earlier videos, 0 below, no go. In mathematics, you can never divide by the number 0. So if you divide by 0, that's wrong. So you can't divide by 0. Then how do I know if it's no solution or if it's all real numbers? Look at what the problem says. This says 0 times what is 10? Now think about that. You tell me, can you multiply 0 by anything and ever get 10? No. So this problem has no solution. This is what we call, in algebra, a contradiction equation. But the answer is no solution. And sometimes it's written this way, 0 with a slash through it. Now that's not 0. This is called the empty set symbol. So you will always recognize the no solution problems because it will always be 0x equals some number. Anytime you run into that, it's no solution. So there is no answer to this problem that would make it true. Now, I said a while ago that if this number in front of x goes to 0, the answer is either no solution or everything works. let me show you one last example on this video. Okay, let's solve this problem just like we do the others. So let's get the x's on one side, numbers on the other. So I'm going to subtract 4 from both sides. When I do, this would be 3x equals to, the 4's add out to 0. 3x, the 4's over here add out to 0. Now, the x's are still on opposite sides. You have to get them on the same side. So, to get this x over here, I'm going to minus it. But I got to minus it over here as well. When I do, this is going to be 0x equals, and then there's nothing left on the right side. Now, I don't have to I can put the x over here too, but 0x and 0 is the same thing. But I'm putting the x over here to show that my x's are on the left side, my numbers are on the right. All right. Now, I said a while ago, if this number goes to 0 in front of the x, you cannot divide by 0. So that's out. So the answer to this problem is either no solution or all real numbers. Let's read it. 0 times what is 0? Well, 0 times 1 is 0. But 0 times 2 is 0. As a matter of fact, 0 times anything is 0. So whenever that happens, this is when the answer is all real numbers. That means everything works. This is what we call identity equation. So, a contradiction equation will always end up 0x equals some number. No solution. An identity equation will always be 0x equals 0. Now, all of the other problems we've worked up until this point, neither one of these happened in all the other problems. The type of problems, all the other problems that we work, those are what we call conditional equations. In other words, they're only true under one condition. This one is true under all conditions. But all of the ones we've worked up until these two, you've had one solution, and they're called conditional equations. So if your variables goes to 0, the answer will either be no solution, if it's 0x equals some number, or all real numbers if it's 0x equals 0. All right, in the next group of problems, we're going to start and make the equations a little bigger on each side.